So, as Elizabeth has mentioned, I represent the Deployment and Operations Committee of the Fibre to the Home Council Europe. The committee is really concerned with issues relating to the construction, implementation and operation of fibre to the home networks. That really is the core activity of the committee. And one of the most pressing issues that we are exploring currently is this issue of convergence. With the emergence of 5G, and as the title slide here says, why 5G can be an enabler for FTTH or vice versa. And I'll explain what we mean by that as we get into the presentation. Now, you're going to have to just forgive me here for a second. I'm going to run very quickly through some of the slides. In fact, I'm going to ignore some of the slides because my colleague, Colin, has already gone through some of this content. He's already explained, and I think everybody here should now be understanding that there is a need for a lot of fibre to be deployed in order to build true 5G networks. So working with that presumption in mind, I really just want to present to you, I'm going to ignore or skip through very quickly the introduction to the concept of convergence and the reason why fibre is required for 5G, and move on quickly to the objectives of the project. So you just bear with me while I move very quickly through these slides. I do want to stop at this one, though, to be very clear. From our perspective, there's a couple of messages on this slide. 5G is not 4G. 5G is different. 5G is better than everything. And I love this quote. Yes, but all magic comes with a price. So what is the price for 5G? It's densification. Densification means far greater number of cells and a far greater amount of capacity, etc., required to build a network. So that is the price for 5G, and what we're concerned with the study is looking at how can we optimize this price? How can we help operators to consider the price or to improve the price? So 5G is about densification and fibre. It is an opportunity for fibre because it is the preferred technology for the required speed and latency. And connectivity is required in every street. When you think about densification, that's what you're talking about, is connectivity over fibre into every street. So I'm going to start here. If we think about fibre deployment, one thing you can be convinced of with fibre is it costs money. And maybe this photograph is a bit extreme in terms of the depth of the trench and how deep the trench is for deploying a fibre cable, but trenching requires high costs. One thing you can do is look at ways to avoid trenching. You can use aerial cable, facade cable, you can look for existing ducts, you can use slot trenching and use mini and micro cables. Find ways to reduce the cost of fibre by using other means of deploying the fibre. So, this is well understood in the fibre to the home world. It's well understood in network construction offices all over the world that there are more cost-effective ways of deploying fibre, and they should be used whenever possible in order to reduce the total capital cost of building a network. But when we look at 5G, so what I want to do now is move into when we consider a 5G construction project. And let's try to look at what will the fibre network that's required to support that 5G deployment, what will it look like? And this is just an example of kind of an illustration of the project that we want to undertake, or that we are undertaking. Sorry, it's not that we want to undertake, that we are going to undertake. So the next couple of slides will just illustrate that to you as we build it up. So if we consider an area, and the area, theoretical area, I'm not even sure where this is, but it's a medium density population area. You've got 12.3 square kilometres, 22,000 inhabitants, 2,700 single dwelling units, and almost 1,000 multiple dwelling units. So if you want to design a 5G network for this region or for this area, you're looking at over 600 cell sites. So think about that. 12.3 square kilometres, 600 cell sites. So it is extremely dense in terms of cell sites compared with 4G or 3G. Okay? So when we do that, and we create a RAN design for that 634 cell sites, we end up with something that looks like this. You end up with fibre in every street. The red points here are aggregation points. The dark blue lines are feeder cables connecting the aggregation points back to central offices. But then you've got all of the other fibre running down every street. So you have a very, very dense connection of fibre required in order to build this 5G small cell network in this area, covering 22,000 people. If you take the same area and you look to build a fibre to the home network, so park or put to one side for the moment the need for 5G, and you look at fibre to the home into the same area, again connecting all of those 22,000 residents, all of those multiple dwelling units and all the single dwelling units, then a fibre to the home design looks something like this. And you end up with one fibre for every home, an underground network based on microduct, and a fibre in every street. So it's quite similar when you look at it at this high level. When we take those two high-level simulated designs and we look at the costs, and this is just an example, right? So the costs, what you end up with is something that will look like this. And there are lots and lots of variables that go into making this up. So please let me be clear. This is built on a set of assumptions, but those assumptions can change and they can vary. You have a fibre to the home standalone cost on the left-hand side. You have the cost of the 5G network in the green pillar. So if you take both of those and you build them independently, you end up spending this amount, the amount in the third pillar, fibre to the home plus 5G. If, however, you look at the two separate networks and you say, right, let's build this once and build all those connections in one construction program with one set of physical assets, we end up with what we call the converged network. And therefore, we see some savings. And it's the savings by convergence that we are really interested to understand as part of the project that the Deployment and Operations Committee is undertaking. This is what we want to understand. How much savings can this deliver for the operators or the project promoters that want to build these networks? There are obviously synergy opportunities when you go to build a converged network. You can share the routes and the trenches that I looked at earlier, perhaps sharing ducts, sharing cables, or sharing fibres and active components. So there are many different ways to achieve the synergy, but the point is that synergy can be achieved. So looking at that and you look at the result, then if you take the cost of the converged network, one way to look at it is that both the 5G network operator and the FTTH network operator can achieve savings. Because if the total cost is reduced, as shown here on the right-hand side, then the 5G operator sees a reduced cost and the FTTH network operator sees a reduced cost, and they share the savings. So, okay? So very simple. We agree to build a shared network and we both save cost. However, there's lots of other opportunities. For example, in a situation where fibre to the home network operator decides, perhaps I should build the 5G infrastructure while I am building the FTTH network. Well, then there's a very small incremental cost in this example for building the 5G network. So potentially the savings on incrementally building a 5G network are quite significant. The same applies if the 5G network builder says, actually, we'll build the 5G, we'll spend the full amount on the 5G, and then we have an incremental cost for building a fibre to the home network. So the results, you can look at it in many different ways. There are many variables. It depends on who is taking the lead, whether it's the 5G company or the fibre to the home company. But the point is that there are savings, and what we want to analyse and understand is how can you quantify those savings. So we've kicked off a project, as Ursula mentioned. It's actually not just Fibre to the Home Council Europe. It's actually an alliance of all the fibre councils around the world. And I want to now just explain the scope and objectives of the project in some detail. Okay? So what the project is intended to do, as I said, demonstrate the potential cost savings of convergence between 5G and fibre to the home or fibre to the building. Illustrate the differences between the various scenarios. So we will have a lot of transparency when we publish this project on the assumptions that are made going into it, because there are so many variables that there is no single case that can be representative to everybody. So we will have full transparency on the assumptions. And we want to illustrate the impact of key factors. So understand what really are the big factors that affect the costs. And therefore stimulate some discussion on the importance of our assumptions and the cost of constraints within the network. Just as important, what we also intend to do, or what we don't intend to do, right, is we will not report just one figure as the true value. There will not be just one answer to this study, okay, because it doesn't exist. Simple as that, okay? And we will look also to avoid deriving a total potential cost saving for any country or any continent, because again, A, there's a lot of input data, and B, there would be a lot of assumptions that would be very hard to make across an entire country or an entire continent. On the assumption side, we are going to be, as I said, very transparent about the assumptions. Some of the key assumptions will be around antenna locations, fibre architecture and fibre design rules, the fibre technology, NG-PON, point-to-point, WDM, etc. Labour rates. Obviously, labour rates in a network build are very different as you move around the world, as you move around Europe, even as you move around individual countries. Labour rates vary significantly between dense urban areas and rural areas. Okay, so the cost of trenching in a dense urban area can be very different from in a rural area. So we will be very transparent around the assumptions and make sure that those variables are clearly understood. So an update on the project, this really summarises it in one slide. Okay, we will have a number of different regions or areas that we will study, ranging from a very dense city centre area, medium density residential area, to a low density rural type area. So we'll look at 3 different geography, topology, population density type of regions within this project. We're going to look at using microcells, using picocells, and therefore giving different sets of backhaul requirements and fibre requirements depending on those. On the fibre side, different models for how the fibre can be deployed and how it can be made available through dark fibre and wholesale, via managed bandwidth, via shared fibre or shared ducts, etc. So we'll look at all those variables, and then some of the detail on the fibre, whether it's underground fibre, aerial overhead fibre, or reuse of existing ducts to avoid building new ducts and burying new duct. And then lastly, we'll look at some of the different, I guess, positions of the potential people who will build, whether we start with separate FTTH and 5G, so we have 2 entities building 2 networks separately, or like I said earlier then, a fully converged network, or a fibre to the home first with 5G built on top, or 5G first with fibre to the home built on top. So we're going to look at all of these different combinations of variables and come to our conclusions. So this work is ongoing. It has been kicked off since the middle of the year, and we expect that we will be in a position to share some of the conclusions at the Fibre to the Home Council conference in Amsterdam in March. Some of the target answers, issues that we hope to address when we do publish the report, is some of the very obvious ones, obviously, the range of overall savings in deployment costs that can be achieved when deploying converged networks. I think that's going to be probably the most important one, and the one people will really want to understand is what range of savings do you think you can achieve by converging these networks? The big factors that influence the savings, I mentioned that already. Very clear, important to understand which variables are a real impact on cost. If deploying fibre for 5G and expansion capacity for fibre to the home, how much cheaper can you make fibre to the home deployment? So this is, probably a little bit from our perspective in the Fibre to the Home Council, looking after our interests to see, can we reduce the cost of fibre to the home by taking advantage of additional capacity in 5G networks? Another question is, will the spare capacity already deployed in some of the fibre to the home networks actually be sufficient for 5G? So this is a concern for many network operators right now as they plan their fibre deployments. They're thinking about building fibre, deploying fibre for fibre to the home, but perhaps they need to deploy extra fibre for 5G as well, because it's coming down the line at them in 2-3 years' time, or even sooner. And some of the other issues, how much cheaper if one operator deploys an infrastructure rather than every service operator overbuilding infrastructure, so you avoid multiple digs. How much cheaper is it for everyone to do that? And then also a focus on fibre and 5G in rural areas. So these are some of the target answers. I'm sure there'll be many others, and like I said, it is hoped and it is intended to publish this report at the Fibre to the Home Council Conference in Europe. Okay, so I'll leave it there. Thank you very much for your attention.